everyone, welcome to my channel Physics Solutions. Today we are going to start with resistors in parallel. So let's continue. We are going to start with by building a circuit. So first we are going to take some connecting wires, battery, some more wires. So as you know that we are going to connect the resistors or any appliance which is in parallel. So here we need to take an ammeter which is going to show me the current flowing in this particular loop, and then some more wires just to make the circuit look neat. I'm making use of more wires. Then we are going to take 3 bulbs. Actually the bulb is in component which is going to have its own resistance. So instead of taking only a resistor, I'm taking a bulb because bulb is also having some resistance. So we are going to connect this bulb, one bulb with this, and then we are supposed to connect a switch also. So let me just connect a switch between battery and ammeter in order to start and stop the circuit. And here we go, we have connected one bulb in one loop. Now next we are going to take some more wires, then connect another bulb. As it is in parallel, so we are not going to connect all the bulbs in line, we are going to connect parallel to each other. So in 2 different or 3 different loops, as we can see, we are going to connect it. Now we are going to take the third bulb, one bulb to the one terminal of the bulb to one end of the wire, then to the other wire. We are going to take the another terminal of the bulb. Like this we complete a circuit. Now this circuit is completed. We need to check the values on each component. So it's a battery over here, then here is a switch, here is an ammeter, here is another bulb. All the 3 bulbs are identical. So you can see it's 10 ohm, 10 ohm, 10 ohm. We can change the resistance of each bulb by clicking on it and increasing and decreasing the resistance. But we are going to keep it same for a while. Now if we switch on the circuit, you are going to get all the 3 bulbs lighted up. As you can see, the current which is coming out of the battery and going into the battery is 2.7 ampere. Now we are going to check the voltage drop across each bulb. So the voltage drop across each bulb is going to be, we can see here it's 9 volt. Now here with another bulb is again 9 volt, and with another bulb is again 9 volt. The voltmeter should be connected parallel across the appliance or the resistor, whatever we are going to check. The component terminals should be connected parallel with the voltmeter. So here we can see both the bulbs or all the 3 bulbs are showing the same voltage. So what we can make out from here, we can see that all the voltage which is coming out of the battery which is providing the voltage 9 volt, it's given equally to all the bulbs. It is not changed, it's not divided. As we have seen in our series circuit, the voltage gets divided. Now let's check about the current in each loop. So now what I am going to do, I am going to connect an ammeter in each of the loops over here. So here we can see how much current is going to flow here in this particular loop across next to each bulb. Now here if I cut this particular wire, I will take another wire and connect an ammeter again. And in this particular loop, we are going to take another wire and take an ammeter. Now from here we are going to come to know that how the current works. So let's switch on the circuit and see. As you can see, in the first loop the current is 0.9 ampere. In the second loop the current is again 0.9 ampere. Third loop the current is 0.9 ampere. We can see 2.7 is equally divided across each loop. That means the current is being divided over here. Why it's equally divided? Because we have taken equal same amount of resistance in each levels in each loop. So we have connected the same resistor or the same appliance of having the same resistor, 10 ohm, 10 ohm, 10 ohm. So these are the three resistances connected in parallel. So they are dividing the current over here, but we can see the voltage remaining the same. So here what we understand, that when the resistors are connected in parallel, the voltage remains same, but the current gets divided, and it's apparent. We can see the electrons are getting different paths to flow. So the first part, some electrons go, the second part some of the electrons go, then remaining electrons go in the third part. So that means the electrons, what is current? Current is nothing but flow of electrons per unit time. So as we can see, electrons are getting divided, so the current will also get divided. So this way 9 3s are 27, so 2.7, 3, 9, 0 0.9, 0 0.9, 0 0.9, when you multiply together you will get 2.7. So as we can see, the Kirchhoff's law is also applicable over here. That means the current is getting divided over here at the three different loops, but at the end the current gets united and it's added up and it goes in the added form towards the battery again. So this is what about resistance in parallel. So we can make a note that resistance in parallel means the current gets divided but voltage remains same. Now let's check if I change the resistance of each bulb. So let's see if I make this resistance of the bulb as 40. So I'm making this resistance as 40. So what happens to the voltage? Let's check the voltage across this bulb. It is going to remain the same. No matter how much is the resistance connected parallel, all the appliances are going to get the same voltage that is coming from the battery. But the current gets affected. As you can see, the current over here is 0.9, 0.9. But when the voltage in the resistance increased, the current became 0.22 ampere. It is reduced. You can see the flow of the electron. It is affected. It is going with less speed in the first loop, but second and third loop it's going with little higher speed. So we can understand the current may differ because of the resistances. As we can know, the resistance and current are inversely related to each other. So this is all about whenever a resistance is connected in parallel, voltage remains same, current gets divided, and also from here we come to know, like if I break this circuit, if I break one of the circuit, if I one of the appliances is not working, what will happen? The other two appliances won't get affected. So this is what is parallel connection is preferred in our household connection system also. We have our connections in our household appliances as a parallel circuit connection, because when one of the appliances stop working, the other appliances still work. If we connect all the appliances in series connection, let's say the fan stops working, then all AC, the TV, the refrigerator, the washing machine, they all will stop working if it's a series connection. That is the reason we have parallel connections in our houses. And the other reason is the voltage should go equal to each appliances. So in series connections the voltage gets divided, but in parallel connection the voltage remains same. So same voltage should go to all the appliances. That is the reason we need parallel connections in our house. Hold connections, electricity. So this is all about resistance in parallel. Thank you.